Hi guys, welcome to another Learn Electronics Repair video. I have a cardboard box here, and there is something in the cardboard box. So first I will just mention this video is sponsored by Banggood. Banggood got in touch with me and asked me if I would like to review some of their products, and I said, hey, if it's electronics repair, tools related and such like to do with electronics repair, why not? So let's see what they have to offer. So this is a power supply, WAMP Tech. It's a well, it has a model NPS3010W. So from the model number, you can probably figure out this is a 30 volt 10 amp. So basically it's 0 to 30 volts, 0 to 10 amps, bench power supply. In fact, although we've just worked it out from the model number, it also tells us exactly there what it is. So the first thing I notice about this is it's smaller and lighter than both of my existing bench power supplies. So let's have a look to see what's in this box. I get an EU power lead because I actually live in the EU. Okay. And I have a power supply, some useful leads, and a instruction book in in English. Instruction book. The front and back are encrypted in Chinese, but the middle bit's in English. So let's have a look to see what it says. And now let's have a look at the power supply. Well, switching power supply, and by the weight of it, I think this will be switch mode rather than linear. Yeah, they're not big, they're not heavy. Output current and controlled by 2 variable resistors. Okay, regulation for more handy. Okay. 230 volts says can be customized for 115. Whether that means it's switchable or whether it's a different model, it doesn't really say, or maybe it just works on the whole range. I mean, quite often switch mode power supplies have a very wide input voltage range, high frequency operation, reduced size of power transistors, entire energy efficiency of 70%. Yeah, zero adjustment for current and voltage. Okay, and we can use it up to 2,000. The top of Gran Canaria island is like 1,950 meters high, so I can use this anywhere on the island. It doesn't specify what would happen if I nip over to Tenerife, which is just across the water and has mounted about 6,000 meters high, whether it would fail if I went higher than a third of the way up the mountain, or if nothing would really happen. Yeah. Well, there we go. It can get above 40 centigrades here in a heat wave or a Kalima, but it's unusual, not in my workshop because I have air conditioning. We can get to the mid-30s on a regular basis in the workshop. Yeah. What else we have? Output voltage from 0 to rated voltage, continuous adjustment, better recovery time and such like, some body boards, yeah. Switched off. So there is a line voltage selector, okay. Connect it up, power it on, adjust the voltage and current to the desired output, connect the external load, make sure it's the right polarity, setting current limit. Well, we should have to do this anyway. I shouldn't have to read this, yeah. Short the leads together, set whatever current you want, and then that's what it will supply. Okay. I don't think we need to know anything much else about this. I'm sure this is like just about any other. Yeah. Enough of that. Let's have a look at it. Okay, so first thoughts, it's small. Yeah, it's small. That may not be a bad thing at all. We can see the controls on it. It has a little peel this off before use. We'll get rid of that. It looks nice, but it kind of like feels like there's nothing much to it. Oh, yeah, okay. So it does have a voltage selector on the back. So all those of you over in the USA, you can just switch this to 110 volts. It's on 230 at the moment, and you can use this. So there's our power supply. I'm just looking inside it a little bit. You can see, I might open this up in a little bit actually. Let's have a look what is inside it. But you can see the PCB in there. Little warranty card, okay. There we go. So I think the first thing is, let's just plug this in. Let's see if it's actually working. I'm assuming it must be if it's new. Voltage amps, watts. Let's see what it looks like. My other power supplies don't have a watts display. Let's give it a go. Okay, I've connected the lasers came with it. I've connected the power. Let's switch it on. It comes on. And you can see it's set to 31.4 volts at the moment, 31.5. I have no load connected to at the moment. Oh, that's interesting. So you turn the voltage down, but with no load, it takes a long time to actually go down to the desired voltage. So I'll just turn it up. Turning up is like instant, but turning it down isn't without a load. Now that might not seem strange because you think, well, there'll be some output capacitors on this, so you would think that would happen anyway, yeah? But let me just show you what happens on my power supply. This is one of my other two power supplies, Levolta BPS305. I think these were basically made under lots of different brand names, and we can switch on. And you'll just notice straight away with no load, it's much more responsive. I'll be honest with you, it doesn't go immediately down. It does have a slight delay. I've never particularly noticed that before. Turn it to 0. That's the first time the knobs fell off it, but it's not really. We're not kind of reviewing this one, yeah. But also you hear this goes tick. Like 4 ranges, yeah. So actually that does have a slight delay. I've never particularly noticed, but it's more pronounced on this new one. Okay. While we're at it, there's my other bench power supply. This is a dual 30 volt 3 amp. So you have two independent 30 volt 3 amps. You can have them in series, which gives you 60 volt 3 amp, or you can have them in parallel, which gives you 30 volt 6 amp. This is like this one, but quite responsive. Okay, so there's nothing that strange about that. I just haven't noticed it so much because it's more marked on this new one. So it's nothing that unusual. I just wanted to mention it. It just seemed a little bit more. Yeah, you can see it's more of a delay. When you set the voltage on this, you have to wait a little bit. Yeah, that's the top and bottom of it. Setting it, let's see, should be quite accurate. We have a coarse and a fine. We'll just try adjusting the fine. Yeah, it's easy to set. It's easy to set. You'd expect it to be. So that is working, yeah. We can just measure the output voltage from this. It's a bit awkward to get it so you can see it on the camera. I'll do that with it. Let's have a look to see how accurate the output voltage is. Okay, so I'll just put the meter here. My fluker's almost 30 years old, so I'm not sure how well calibrated it is, I have to say. During that time I use it for repair work, so it's not exactly that important to me. Well, let's see. Well, I have 9 volts set on the front, and that's giving me 9.09. I'll set it down so this actually says 9. And this actually still says 9. Yeah. So the fact this actually goes up by 0.1 of a volt, 9.1. You can kind of, yeah, that makes some sense because this is actually going up 0.1 of a volt at a time. Yeah. So if you want to, you can actually set the meter and it will read the same as the supply, 9.10. So that's fine. That's fine. Okay, let's set it down to, say, for example, 5 volts. That's a common voltage supply to use in repair work. Just set it with a 5. We'll set it as close as we like. Yeah. Okay, 5 volts. I've turned the current up a little bit, but it's quite low. Let's short our 2 leads together and see what we get. So we should get whatever current it's set to. 1.72 amps, and as you see, the voltage has gone down to 0.01 because I'm running into a short. So obviously it reduces the voltage to set so it can effectively deliver the current we want. Just one there. Just put them back together. We can turn the current down to 0. The fine's down to 0. What's the least we can actually set the current to? Well, again, I will say with this, I have this slight delay effect. I can turn it up a little bit. You see, then it comes up afterwards. So I adjust that. It's a bit unresponsive, I would say. I mean, it's doing the job. I have 100 milliamps, yeah. I have 100 milliamps. What happens if we turn the current up? I mean, these leads, I'm not sure how much they'll handle. We're on 10 amps, yeah. We're on 10 amps. The leads are warming up. Yeah. You can see the wattage is low because it obviously keeps the voltage low into a short. This is just cold. The leads are getting warm, you'd expect. So it looks, from what I've seen so far, can wait a bit longer, that this can actually, there's no fans in it, so don't hear any ventilation come on, but it seems very happy to deliver 10 amps and warming these leads up quite happily. Yeah. Oh, something went click. Made me jump. It was a crocodile clip lead. Yeah. It was a crocodile clip lead off. Disconnect itself. You'd expect the leads to warm up, which they are doing. This is quite happy delivering 10 amps. Yeah, quite happily delivering 10 amps into a short. Let's give it a bit more work to do. I have some 50 watt 12 volt halogen lamps here. I have 3. I obviously use the 4th one for some sort of repair, but each one of these 50 watts 12 volts is about 4 amps. So the 3 of them together should draw, well, 12 amps near enough. Yeah, just over in fact. So let's try a couple of these first. So let's put an 8 amp load on this and see how happily it runs. So what I think I'll just do is I'll just switch it off a moment. I'll clip my bulb on here. I probably don't want to rest it on something actually, because it's going to get pretty hot, I would think. So there is one bulb. Let's just put the leads a little bit further apart where we can get at it. Okay, so there we have one bulb. I suspect it's going to get a bit bright as well, yeah. So let's switch her on. Well, straight away we're in constant current mode because I actually have the current turned down, yeah, 0.7 amp. So let's increase the current. Current up to maximum now. It's on 5 volts, so let's turn this up. In fact, the glare is going to be so bright you won't see it, so let me just move it slightly out of the way. Yeah, let's give it some load. So up to 12 volts on this. Okay, I have to put something in front of that because it's actually just stupidly bright in my eyes. Bit of cardboard which might set on fire. I'll just keep an eye on it. So it's quite happily delivering 4.2 amps into that. But you'd expect it to. You'd expect it not to have any problem with that. 52 watts, you can see, and we know the 50 watt bulbs, and my bit of cardboard is now smouldering, yeah? Oh, My bit of cobalt is also hot enough to burn your fingers. But you'd expect that if it's resting on top of the lamp, yeah? So, I'll find a slightly better way of doing that. Let's connect another one. Okay, I've put another one on. Let's see what it does. So we'll just switch it on. Both lamps are on. 8.3 amps, what you'd expect. I mean, this thing is silent. There's no fans in it. It's quiet. It doesn't seem to have any problem whatsoever running that load. I suspect I'll have to turn it off before my bench starts to burn. But with 100 watts, it's quite happy. Yeah, it's quite happy. We can reduce the current. Yeah, it works quite nicely. So the constant current is fine. I'd be quite happy to use this for short circuit finding, that is for sure. I don't have anything I can easily just load it a little bit more, unfortunately. I would be nice to get it up to its full wattage, but I honestly don't think it's going to have a problem in doing so, to be quite honest. And this is quite a cheap device. I mean, let's not be mistaken here. These, I think I've seen them as low as €47. Obviously here where there's no VAT, that's about €40, so that's good. That is good, to be quite honest. It feels a little bit cheap, but it is cheap. Yeah, you've got to give it that where it's due the credit. So just from that bulb's hot, just cut the back of my hands. It was bound to be hot. Just from a preliminary check like that, I'm quite confident with this. I'm quite happy with it. Let's have a look to see what's inside it. Well, it's easy to open up, just 4 screws each side. So that's what's inside it. I'm guessing this is a heat sink. It's not just there to mount the PCB. So that's what's actually inside it. As we knew, it would be a switch mode power supply. There's an earth connection, there's a ground connection going to the PCB. I've noticed there's no ground connection on the front of it. Both my other power supplies actually have a ground connection, although to be quite honest, I don't particularly use them. On my little Lavolta, there's like a tag which connects the negative terminal to ground. On the other one, you have to manually connect something to ground. But actually, you know what I use that ground terminal for? Connecting my anti-static mat. That's what I use it for. So, this is what's inside it. Looks like a fairly hefty MOSFET down here, a couple more. Possibly, these are probably diodes actually, these are probably rectifier diodes, I'm guessing. This is a bridge rectifier on the input, so your power, it comes in here through the filters, through the bridge rectifier into the main smoothing capacitors, 470 microfarad, 250 volts. 2 of them, so this would probably be a power supply like the ones you find in ATX and LLC bridge. Yeah, look, there's the capacity you'd expect to find. So that's how it is. And it looks fairly well built to me. I mean, all the wiring's attached firmly. I don't have any particular issue with that. Let's have a look to see how much noise we get on the output, how much ripple we get on this. Okay, I have the power supply on 12 volts still. I've put my digital scope on because you can actually read the readout. If I touch the end of the scope ray with my finger, I have about, well, all over the place, but over a volt, 1.8 volts of noise or something, yeah. So that's just picking up mains hum. Let's connect it to the power supply. So there we go. So it's telling me I have like about 20 millivolts of noise. I'm on the 500 millivolts per division. I'm on AC coupling so the trace doesn't go off the screen. Let's turn the sensitivity up a little bit. Yeah, I'm on 100 millivolts per division. Yeah, and you can see a bit of something there. And it's generally giving me about 8 millivolts. 12 millivolts. So there is a bit of noise there, but it's not a lot. So I think it's settled down. 80 millivolts, 40 millivolts. So that's what I'm getting in the way of noise. Now it's gone to 0, even though the power supply is still on. Let's try connecting one of our bulbs again. Let's just give it a bit of a load and see if that actually puts any more noise out than it does at the moment. And we have about 40 millivolts of noise again, so the noise figure really hasn't made any difference whether I have a load on the power supply or not. So that's good, that's good. What would be nice to see is a separate switch on here, so you can switch the power supply on but switch the output off, and then switch the output on when you like. I mean, one of the things you can find with power supplies is overshoot when you first switch them on, but I always tend to switch them on and then connect the load anyway, to be quite honest, which kind of like gets around that sort of problem. I'll be honest though, neither of my other power supplies, which are quite a bit more expensive than this one, actually have a separate switch for switch the output on and off. I mean, some do, mine don't. So I actually built this, which I use with my power supplies. It's a simple box. You have 2 sockets, another 2 here, an on-off switch, so I connect my power supply into here. This goes off to whatever I'm working on, and this will switch the output on or off when the power supply is on. This little LED comes on when it's running, which is fine, but you do have to remember this actually draws 10 milliamps, so even when the load's drawing 0, the power supply will show 10 milliamps, which is effectively the resolution of my power supply meters, 0.01 of an amp. Yeah, so all you have to do is remember to deduct 10 milliamps from the current your device that you're testing is drawing. But yeah, it works fine. So you can connect that to this just the same as I had to make this to connect to my other power supplies, which were considerably more expensive than this one. So there we have it, guys. I'll just mention there's a few versions of this. So there's versions which are 6 amp, which are 10 amp, and then there's a 60 volt version, the 120 volt version, and various currents. So the cheap ones I saw, which were about 45 euros, were actually the 6 amp versions when I looked again. The 10 amp versions of this are about 70 euros, but that's with VAT in the EU, which is about 20%. So for me to order here would be, well, 21% less than 72, yeah? So you're looking around about 60. I guess this depends on where you are in the world, how much you would pay. One other thing with these, there's a model, or rather each model comes in a 3-digit and 4-digit version. This is the 3 digits version. So the 4-digit display effectively has like an extra precision on the voltage, on the current. So rather than reading to 0.1, it reads to 0.01. How useful that is a bit debatable for repair work, but having said that, the difference in price between the 3-digit and 4-digit is very small, so I suspect for a few euros more you would have the 4-digit version. I mean, this is the one they sent me. I'm quite happy with it. If they sent me the 4-digit one, I'd be quite happy with it plus a decimal point, yeah? So there you go. So you can probably see my opinion about this. It feels a little bit cheap, I think, because it feels a little bit light, but it's solidly made. And it is quite cheap. It's not an expensive device, so you kind of like get what you pay for. It's what it says on the tin. I'd be quite happy to use this for repair work. In fact, I will use it on the channel. I'll put it next to my 5 amp one, and when I'm trying to trace some short circuits to see what gets hot and I can't get enough power in using the 5 amp, I'll certainly use this one, yeah? If not only that, I can put it against my other power supply and have plus and minus 30 volts at 5 amps, whereas my dual one only give you plus and minus 30 at 3, so it's a nice thing to have. You could buy 2 of them, put them together, and you've got a plus and minus 10 amp, plus and minus 30 volt supply, or in series 60 volts 10 amps. So I'd have to say that if you're looking for a bench power supply for hobby work, for repair work, as far as I can see, this does the job. It does what you'd want it to do. It does what it says on the tin. It doesn't take much space on the bench. I do like that about it. and I'm sure I will find use for it. I'm sure if you bought one, you would also find use for it. So I have to say, yeah, I can recommend it. There's nothing special about it, but you know, it's good. It's good. I don't think you'd find anything better at the price, but somebody, hey, you're going to tell me I'm wrong there, yeah. But yeah, if you need a power supply, bench power supply, and you're on a bit of a budget, and that's within your budget, buy one. Okay, guys, hope you enjoyed that one. I look forward to seeing you all on another Learn Electronics Repair video, and all that's left to say now is ciao for now, guys.